Imagine somebody who is exactly like yourself living in a totally different world at a different time. Confused? While this may sound frightening, it is not. Though some scientists disregard the theory as fantasy, others swear by it. Firstly, we are not even sure if there is life anywhere else apart from the Earth in this universe. Now picture having the exact same image and persona of yourself in a totally different universe billions of light years away. Apparently, the first of these has been found. Welcome to Futured. Today we'll be talking about the first ever parallel universe that has finally been discovered. Before we do, subscribe to our channel to get updated with everything on future technology, Elon Musk, or SpaceX. Scientists say that there might be another virtual world out there sitting alongside ours called parallel universes. This concept looks like something out of a science fiction novel or film, and there's been plenty of both over the years to pique readers' and viewers' interest. Parallel universes were first proposed in 1954 by Hugh Everett III, a Princeton University student who presented the controversial idea that parallel worlds, or universes that look precisely like and are related to our own, exist. These parallel universes splinter from our own as they splinter off others. This audacious idea has numerous practical implications, since it indicates that global conflicts in parallel worlds could have different results. For example, dinosaurs may have existed or may now exist in specific parallel universes. In fact, humans may have become extinct in some parallel universes. Many express skepticism about this young scientist and his daring notion. Still, as it became known, Everett's many worlds hypothesis was his personal attempt to solve some unanswered problems in the findings of tests conducted on the burgeoning field of quantum physics. Quantum physics is the study of things at the quantum level, which is the minutest level that scientists have discovered so far. Quantum matter, which remains on the subatomic level, appears to be in contrast to the orderliness that is seen in other spheres. This has prompted scientists at work which we are unaware of. For example, scientists investigating quantum physics notice that quantum particles like photons appear to take different shapes arbitrarily. The photons discovered behaved like particles at times and like waveforms in another. This could be related to the theory of you being a human at one time and gas the very next. Werner Heisenberg, a physicist, proposed that we can influence quantum matter's behavior simply by looking at it strangely. Physicist Niels Bohr agreed, but went a step further by suggesting that quantum effects exist in all possible states at the same time and that our perception impacts their behavior, forcing them to choose a state at that particular moment in time. Everett's many worlds theory can be considered an alternative to Bohr's view of quantum matter. Observing quantum matter, according to Everett, causes the universe to split rather than flip between states. So the cosmos replicates and splits into several parallel universes with each possible quantum state. If you've ever been in a position where one possible consequence was death, then Everett's theory states that there is a parallel universe where you have already died. Everett's method was particularly divisive because it contradicts our fundamental conception of time. For many years, scientists dismissed Everett's theory as far-fetched, but it has recently found some ground. While Everett's theory is being put to test, another hypothesis, known as string theory, asserts that particles much smaller than quantum matter exist. Parallel worlds are also claimed to exist by string theory, but if we work our way backward from the Big Bang, we will almost certainly end up with parallel universes. The universe as we know it began 13.8 billion years ago during the Big Bang. Back then, the universe was hot, dense, and filled with plasma particles. It was expanding, cooling, and leaning from that initial state. The farther folks look back in space, the farther we wind up back in time, all the way to the hot Big Bang's boundary. If the universe had exceeded some specific temperature and density, the universe would have exploded. Data are significantly compatible with the idea that the Big Bang was hot and set up by only a period of cosmic inflation that stretched the universe's curvature to the point where it was indistinguishable. Everything we know was an infinitesimal point around 13.7 billion years ago. Then it exploded, expanding at the speed of vision in all areas for a fraction of a second, as per Big Bang theory. In a process known as cosmic inflation, the cosmos blasted outward to 1,026 times the actual size in less than 10 to 32 seconds. And that's before the real expansion of matter, known as the Big Bang, which was a result of all this inflation. As inflation slowed, a torrent of matter and radiation poured into the universe, forming the traditional Big Bang fireball and the atoms, molecules, stars, and galaxies that now inhabit the vastness is space that surrounds us. Because the expanding universe constantly creates new space, all other possibilities can coexist in various parts of the expanding universe. As inflation stretches the cosmos and produces new space in certain areas, the sphere rolls into the valley, bringing inflation to a close. As a result, scorching huge bangs are created in certain areas. We might term the universe between all those universes as additional inflating space, because inflation does not stop but continues, resulting in the creation of new space because the universe expands in other directions. The Antarctic Impulsive Transient Antenna (ANITA) project, a high-altitude helium balloon with a network of radio antennas partially supported by NASA, discovered a number of occurrences of what appeared to be highly powerful neutrinos coming through the Earth. These neutrinos were detected by the telescope when they came from space and collided with the ice cap in Antarctica. These particles were spotted by ANITA, however, instead of arriving from space, the neutrinos were discovered to be emanating from the Earth's surface with no apparent source. These detections occurred in 2016 and again in 2018, with no credible explanation provided. Low-energy particles designated as neutrinos can flow directly through the Earth without reacting with anything, but are 100 times more effective than anything we could create independently. In contrast, higher energy objects are brought to a halt by the Earth's solid matter. This means we can only detect high-energy particles as they fall from the sky, whereas detecting a heavier particle known as either a tau neutrino that rises from the ground may move backward in time. Some theorists have proposed that the collision of two universes could leave cold or hot spots upon that cosmic microwave background, the afterglow of the Big Bang. This could indicate the existence of a parallel universe. However, many scientists have dismissed the occurrence noticed by ANITA, arguing that while the discovery is intriguing, it is attributable to various factors other than parallel universes. However, it's not unexpected that astronomers thought our planet was alone in the past and later isolated our solar system. So the involvement of two universes isn't a theory to dismiss. But how can we test it? Well, if our world collided with another, it would provide evidence. Gravitational waves, vibrations in this time-space continuum could also indicate cosmic inflation. Suppose researchers can identify such curls in the CMB as we thought they did back in 2014. In that case, the hypothesis assumes that gravitational waves left behind from the Big Bang might put tiny curls in the CMB, which some observatories are actively hunting for today. If this is the case, improved sky surveys should identify those spots. It may eventually increase support for the idea that you are out there living a miserable life during an alternate universe, asserting sci-fi writers resolve once more. However, there is a link for both parallel universes rather than to other enigmatic and terrifying space phenomena, black holes and white holes. Black holes are those disturbing objects through deep space that swallow everything that comes close to them. They are formed when massive stars collide on themselves, creating very thick masses with a gravitational pull so strong that nothing, not even light, can escape their attraction. White holes are the absolute opposite of black holes in that they push everything out and nothing can still go inside. Essentially, every white hole could generate other Big Bangs, generating multiple universes within or outside radius or boundaries. Thus, the laws of physics could be different, and antimatter or conceivably time would not be optimistically unidirectional, and these planets would mirror our universe. That's all for now. Don't forget to subscribe to our channel to get updated with everything on future technology, Elon Musk, or SpaceX.